Hey all, we are going to study to review for your test that is going to be Thursday on Unit 0, which is just pretty much a lot of basic review stuff that we have done just to kind of get you started for algebra. So review the following on the calculator. Let's make sure we know how to do all this stuff on the calculator. So let me pull up my calculator. Add, subtract, multiply, divide. Remember, the add, subtract, multiply, divide are on the side here. Your negative, the negative sign, if you're making a number negative, that's below your 3. Look when I put in a negative, look when I put in a subtraction. There's a big difference there. Don't mix them up. If you do, it's going to tell you there's an error. If you are squaring a negative number, make sure you put that in parentheses. So if I'm doing -2 squared, I want to put it in parentheses, use my upside down V, which is above the division, or my caret, and then put whatever exponent I need. Okay, remember, if you don't put it in parentheses to show that you're squaring the negative, it's not going to do it. Remember, to make a fraction, we do alpha, y equals number 1 for numerator / denominator. Say it's a 4 in the numerator, go down, it's an 8 in the denominator, go over. Make sure you use the over arrow to stop that fraction, and then if you want to times it by whatever. Okay, so those are just some basic things on your calculator to make sure. Remember, with your order of operations, you can go ahead and put the whole entire thing in the calculator just the way you see it, or you can do chunks of it. The one biggest thing I want you to remember, what are these bars? Those bars are absolute value. What is absolute value? That is the distance away from 0 on a number line. Think about distance. The distance, how far it is away from 0 on a number line. Can distance ever be negative? No, distance is always positive, so keep that in mind. All right, let's refresh really quick on the real number system. We did these notes on the real number system. This was our very first Google Meets on Friday, 9/11. A lot of you didn't show up, which then made you have a really hard time to understand this. There was a video posted on that day as well as me going over this. So let's run through it really quick. Remember, every number is a real number. All numbers are real. And then they break into different families. From there, they break into irrational or rational. Irrational numbers are decimals that never end and have no repeating pattern. Decimals that don't end and have no repeating pattern. Pi is a decimal that doesn't end. Radical 2, that is a non-perfect square. That's automatically going to be irrational. The square root of -101, that's a non-perfect square. There's no number times itself that gives me 101. Therefore, it is irrational. So decimals that never end and have no repeating pattern. You could see a number like 7.1935128 Those dots at the end tell me it keeps going on and on and on. That is irrational. Okay, so real numbers break into irrational or rational. The definition for rational is all fractions and decimals that end or have a repeating pattern. So, rational numbers, a fraction, a decimal that ends. That decimal stops. It stops after the 7. The square root of 16. Why is that a rational number? What is the square root of 16? What number times itself gives me 16? And that would be 4. Since it's a perfect square, it's rational. Okay? Another thing that would be a rational number is a repeating decimal. 0.67, and I'm repeating that. Okay, that's going to repeat that pattern the whole entire time. Integers are all negative numbers, all positive numbers. No decimals or fractions. Whole numbers start at 0, go to all your positives. Natural numbers start at 1, go to all your positives. Okay, so just a little refresher on that. Let's see if we can answer some questions. Identify the sets of numbers to which each number belongs. So we want to say whether it's any of these or all of them or one of them. It doesn't matter. Remember, every number is a real number, so I don't necessarily have to put the real number part down. 12. Is 12 a natural number? It is. It's a whole number, it's an integer, and it's a rational. It's all of those things. Is -5 a natural? Oops. Rational is really Q. R is your real. And technically, Z is really an integer. I is your irrational. So it's a natural, a whole, an integer, and a rational. -5 is not a natural, it's not a whole. -5 is an integer. So put my Z for integer. And -5 is rational. If it's rational, it cannot be irrational. 0.3 repeating, that's a repeating decimal. A repeating decimal is automatically rational. It is nothing else below it. That's it. Is 0 a natural number? Nope. It is a whole number. It certainly is an integer. And it's irrational. If it's rational, it cannot be irrational. This decimal, does it end? No, those dots at the end tell me it doesn't end. And there's no repeating pattern. That automatically is irrational. If it's irrational, it cannot be anything else. The square root of 2 cannot be reduced. What number times itself gives me 2? Oops, I told you the answer. What number times itself gives me 4? So the square root of 4 is 2. So now I need to look at the number 2. Is 2 natural? It is. It's whole. It's an integer. And it's rational. If it's rational, it cannot be irrational. 5/3, a fraction. A fraction is rational. Does that fraction reduce easily? Check. 5 divided by 3. No, it doesn't. It's a repeating decimal. It's 1.6 repeating. So that's rational, but it's not anything else. It can't be natural, whole, or integer. And pi is a 3.14, blah, 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 blah. It keeps going. I don't ever know when it ends. So that automatically is irrational because it is a decimal that does not end. Order of operations. I can use order of operations to solve. All right, let's look at what we got here. We got a fraction. I can't do anything in the numerator. Remember, order of operations, PEMDAS. Okay, so I got nothing in the numerator to do. In the denominator, I can do my exponent. So leave the 1. 1 plus 2 squared is 4. Now I have to finish the denominator. So 1 plus 4 is 5. Now I can go ahead and do the whole fraction part because I've simplified as much as possible. What should I do first on number 2? Parentheses come first. So leave your 4 squared. 4 minus 2 is 2. Exponent comes next. 4 squared is 16. And then I'm just left with 16 minus 2, which is 14. Remember, you can check yourself on the calculator. I'm going to show you for this one how to put it in the calculator. So if you go to alpha y equals, because the whole thing's a fraction, number 1 for numerator and denominator, put the whole thing, all the numerator in. The denominator is 4. I should get 3. Let's make sure I understand why. If I look at that numerator, what do I do first? I have addition and subtraction. When you have addition and subtraction next to each other, remember you go from left to right. So 8 plus 3 is 11. 11 minus 5 is 6. 6 plus 6 is 12. And then I have a 4 in the denominator, and 12 divided by 4 is 3. Okay, so I think you get the gist of this. Just remember, show your work, show your steps. You can always double check yourself in that calculator, but you have to have your work. So you know how to show it out. That's going to be an important part of your test. You can try these last couple ones to help you to prepare for your test, and then double check yourself in the calculator. Be cautious of how you put it in the calculator. All right, evaluating expressions. So I want to make sure I can evaluate each expression using the given values for the certain variables. So if I look at number 1, I have x squared plus 2 times y plus 3. X is -3. That means wherever I see X, I plug in -3. And Y is -1. Wherever I see Y, I plug in -1. All right, so let's go ahead and do that. X squared. Well, X is negative. I need to make sure when I'm squaring a negative, I put it in parentheses. So I'm going to do it up here. I didn't leave myself much room, but -3 squared plus 2 parentheses Y, which is -1, plus 3. Think about your order of operations. What comes first? Parentheses comes first, so I have to do that. So leave everything else. Bring this right down. So -3 squared plus 2 times -1 plus 3 is 2. After parentheses comes your exponent, -3 squared. Remember, you know what that means. That means -3 times -3. A negative times a negative is a positive. If you jump to your calculator to check, whenever you're squaring a negative, it has got to be in parentheses. If you don't put it in parentheses, look what's going to happen. And we've gone over this a few times. Why did it give you the wrong answer? If you don't put it in parentheses, you're telling the calculator, I only want to square the 3. I don't want to square the negative. So leave the negative, square the 3, and that's how I got the wrong answer. So be cautious there. So I did my exponent. Does addition or multiplication come next? Very good, multiplication. And now I can do my addition. Okay? That is your work. You know how to show your work. Could I have double checked myself on the calculator and put this whole entire thing in to make sure I get that answer? I sure can. But show your work or you don't get credit. You know that. All right, let's look at number 2 and then I'll leave the rest for you to try on your own. So number 2, those bars, I just refreshed your memory. Absolute value of z minus 2 minus x times y. So I got an x, plug it in where I see x. I got a y, plug it in where I see y. I got a z, plug it in where I see z. So I'm going to rewrite the whole thing. Absolute value of z minus 2 minus xy. When they're next to each other, that's multiplication. So x times y would be 4 times -2. So I've substituted the way I need. Parentheses first. Remember, your absolute value is kind of like parentheses. So it's asking me to first do 0 minus 2, which is -2. And then I can take the absolute value. How far away is -2 from 0 on a number line? It's 2 units. Yes, this is kind of parentheses, but it's really just multiplication. So multiplication would become before subtraction, so leave my 2. 4 times -2 is -8. Or you could have looked at it this way. Some people look at it this way. They would say leave the 2. -4 times -2 is +8. These two things mean the same exact thing. When you are subtracting with a negative, a double negative really becomes a positive. So it really is the same thing as 2 plus 8, which is 10. All right, you can check 3 and 4 on your own if you would like to kind of give you some practice. You don't have to worry about 5 or 6. All right, let's make sure we can identify coefficients, terms, like terms, exponents. Remember, coefficients are your numbers in front of your variables. So if I give you an example, underline the coefficient here. The coefficient is the number in front of your variable. So -3 is your coefficient. If I put 7x squared, what is the coefficient there? 7 is your coefficient. Terms, like terms, exponents, we're just putting together what belongs together. So let's look at some examples on that. I can simplify expressions by combining like terms. So let's look at number 1. I'm going to kind of jump around here and then let you do some on your own. Number 1, 2x squared. X squareds go with x squareds, and it looks to me like there's a like term. Keep the like term. Do what the numbers say. 2 plus 6 is 8. Actually, I think we might have done this one in class yesterday. as a warm-up, or today if you're, do I have any x to go with that 5x? I don't, so leave it. Do I have any 9 to go with that, or a plain constant number to go with that? I don't, so leave it. Check one last time, are any of these like terms? They are not. You are done. Let's look at number 7. Something to remember here on number 7 is I have parentheses. I've got to get rid of parentheses first. So remember, to get rid of parentheses, you distribute. Another thing that I wanted to point out is this negative n. What is the coefficient? What is the number in front of n if I don't see it? It would be a 1. So that really is negative 1n. So let's leave that negative 1n. Let's distribute to get rid of parentheses. When I distribute, I multiply. Positive 10 times n is plus 10n. Positive 10 times positive 4 is plus 40. Now check here to see, do I have any more like terms? I do, n's with n's, so keep the n. Do what the numbers ahead of them say. Negative 1 plus 10 is 9n. Do I have any plain number to go with that one? I do not, so flip the 40 at the end. Last check. Are any of these like terms? They are not. You have fully simplified. Let's look at number 4. N's go with n's, n cubed go with n cubed. 10n, do I have anything else to go with it? I don't, so leave it. And n3, do I have another n3 to go with it? I do. And that's a positive 3n3 plus 9n3. Keep the like term. 3 plus 9 is positive 12. Can I add these? I cannot. They are not like terms. That is it. I am done. One last one, and then you can try some on your own to help you. Let's look at number 10. I got lots of parentheses there, so I need to distribute to get rid of my parentheses. First, I'm going to distribute the negative 10. Then I'm going to distribute, be very careful, that's a negative 6. So I'm distributing negative numbers here both times. So let's check. Negative 10 times 7 is negative 70. Negative 10 times, what kind of p is that? That's a negative 1p. So negative times negative is positive. 10 times 1p would be positive 10p. Negative 6 times p is just minus 6p. Negative 6 times negative 4 is positive 24. Now always check. I got rid of parentheses. Do I have any more like terms? Negative 70 goes with my plus 24. So what would that be? Negative 46? Then always check yourself on a calculator. Negative 70 plus 24, check. And then I have positive 10p minus 6p. 10 minus 6 is positive 4, and leave the like term at the end. And I'm done. There's no more like terms. All right, translating verbal expressions. There's a couple we need to be careful with here. And I don't think I put any on here that we need to be careful with. Remember, you need to be very careful with less than or subtracted by. Remember, those are your turnaround words where you put the first part goes second and the second part would come first. So be cautious on those. The other thing to be cautious about is times the sum and times the difference. That means you've got to use parentheses. Okay? All right, let's go ahead. 12 divided by the sum of x and 2. So 12 divided by, sum means to add. So I'm adding x and 2. If you were to write the other division, 12 divided by, you would need to make sure you put that sum in parentheses. So be cautious there. I prefer to do division as a fraction. Just makes it easier, and that's usually the way you're going to see it. All right, let's try 4. 14 more than the difference of x and y. So 14 more than is plus. The difference of x and y means I want to subtract x minus y. I'm taking the difference there. Okay, but I have 14 more than it, so I need to use parentheses there to show I want that difference first, and then I can take it. All right, let's refresh really quick on these. Remember, here's your x-axis, here's your y-axis, your vertical axis, your x is your horizontal. This center part is your origin. If I go right on the horizontal x-axis, those are positives. If I go left, those are negatives. If I go up on the vertical y, those are positives. If I go down on the vertical y-axis, those are negatives. Remember, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Another thing to remember that you have in your notes as well, an ordered pair is x and y. Any point in the first quadrant will be a positive x and a positive y. Any point in the second quadrant will be a negative x and a positive y. Any point in the third quadrant will be a negative y and a negative x and negative y. And any point in the fourth quadrant will be a positive x and a negative y. Write each ordered pair. So L. Where's L? L is over here. So if I start at the origin, I do my horizontal axis first, my x first. So I have to go left 1, 2, 3, 4, 7. So negative 7. And then I have to go up. When I go up on the y, that's positive 1, 2, 3, 4, 5. So negative 7, 5. Point 0 is right here. So if I start at the origin, I do my horizontal axis first. I need to go right, which is positive x's. So right 3, that's positive 3. And down to it on the y vertical, which would be negative 2. I'm kind of going to jump around because I want to try one in every point. So let's jump to H. Point H. That's over here in the third quadrant. Remember, you do your horizontal first, so I have to go left on the x-axis all the way over to negative 8. And then I would have to go down to get to my point on the vertical y-axis. And if I go down, that's also negative, and I'm going down to negative 4. And let's try G, point B. Point B is all the way over here. So if I start at my origin, I go either left or right first. It looks to me like I have to go right first. So I go right, positive 4. And then it looks to me like for the y-axis, I need to go down. Oh, wait, positive 5. I didn't go over enough. It's positive 5, and it's down to negative 9. Okay, if you have any questions while you're home studying, preparing for your test, email me or send me a remind message. But I know you'll all do great. Remember, it's open notebook. You'll have your notes with you tomorrow.